In this video we'll show you how we can machine this part. We've started the 3D CAM product and imported the step file. So the first thing I need to do is to establish my 0 position. To do that I use the milling ribbon and setup. So this will be the post processor that I will be using, and this will give me the tool change position as well. If we go to set origin, then we can choose where we want the XY0 of this part to be. In this case I'll make it the midpoint in X and Y and the maximum in Z. So that moves the part onto the datum, and if we go into the view mode we can see now that the XYZ position is in the center of that part. The first operation we'll produce is a roughing operation. So we go into the milling tab and we choose advanced machining. Here we set the speeds and feeds. In this instance I'll also check the rapid retract. The tool we want to use will start off with a 20mm end mill, and then the surface paths will use triangle mesh and we'll use roughing. So I need to choose the machining surfaces. So this is the part we want to machine, and if I want to I can leave a finishing allowance either on the overall shape or on the sides and the base. The heights that we're going to be machining will be taken from the machining surfaces, or we can add our own heights here. If we don't know the values we can choose from the screen. The types of roughing that we've got are offset, where the overall shape is offset inwards. We can use parallel and set the angle and the step over, or we can use adaptive where the tool load remains constant. So in this example we'll just use the offset style. The constant depth step here is the depth in Z that we want to use, and the maximum step over here is the step over between each pass in X and Y. The roughing pass here allows me to set up the stock definition. So we'll have the stock as a bounding box and we'll expand it by 10mm. The ramp type is set to automatic, and it will choose which is the best ramp approach move when it's machining that. So if we're happy with that we can click OK. And that is now calculating the new toolpath. The progress is seen on the left hand side here. Okay, so that's the toolpath that's been created. If we want to simulate that, I just need to save this file away. And now I can go back into milling and simulate. And I will build the stock model from the extents of the part. So these are the values of the minimum and maximum extents of the toolpath. I can modify these if I need to. So now the simulator is preparing the part, and when that's ready we'll see the stock material and the tool that we've used. If we use the video controls at the top, we can run the simulation. When the part toolpath is being created, we can control the amount of steps that are taken and also where the tool rapids to between each successive pass. So if we need to minimize the amount of Z movements, then we can do that. So if I stop this simulation, okay, so we can see the blue moves are feed rate, the yellow moves are rapid. If we go into this operation again and we go to the links menu, then here we can go directly between each cut rather than going between the rapid planes. So that now cuts down significantly the number of movements in the Z-axis. So the style of the machining we can change to suit the component. If we go back into here, we could choose a parallel path, and again that is now recalculating the path based on the tool sizes and the overlap and step down that we've used. So that's how we would rough out this part. Another option that we may use is that if the depth step that we've used does not coincide with a flat area, then it will go back and find those flat areas and machine them. We'll come on to the other parts in the next video.